So, what's the deal with how things move? How do they get going? How do they stop? How do they change direction? It all comes down to two absolutely crucial ideas that, honestly, explain pretty much everything. We're talking about impulse and momentum.
And to kick things off, just look at this picture. I mean, seriously, you've got this little tugboat and it is pushing around an absolutely colossal container ship. How is that even possible? It looks like it shouldn't work.
And that right there is the big question we're going to tackle today. How can something so tiny make something so massive change what it's doing? Well, the secret is all in the physics. Okay, let's dive into this.
To even start to answer that, we need a word. We need a way to talk about how much unstoppability something has. And luckily, physicists have a perfect word for it: momentum.
The best way to think about it is just motion strength, or maybe even oomph. A bowling ball rolling down the alley has a ton of oomph because it's heavy. But then a tiny bullet has an incredible amount of oomph too because it's moving ridiculously fast. That's momentum.
But here's the thing. An object's motion strength isn't just one simple idea. I mean, something can be moving in a straight line, right? Or it could be spinning in place. And physics has a way to describe both of these. First, you've got your linear momentum. Now, that formula, L equals mvg, it's actually super simple. It just means you take an object's mass, how heavy it is, and multiply it by its velocity, how fast it's going. It is literally its straight line oomph. Makes sense, right? The heavier and faster it is, the more momentum it's got.
And then you have angular momentum. This is its spinning oomph. The formula looks a little trickier, but the idea is pretty much the same. It's about how an object's mass is spread out and how fast it's spinning. Think about a figure skater. When they pull their arms in, they're changing how their mass is distributed, and bam, they spin way, way faster. They're actually playing with their angular momentum right there on the ice.
So, let's just break that down. You've got two basic ways to move: translation, which is just going from point A to point B, and rotation, which is spinning around one spot. And of course, something can do both at the same time, right? Like a perfect spiral pass with a football. It's moving forward and it's spinning.
Okay, so if momentum is the motion strength an object already has, what actually changes it? You can't just change momentum out of thin air. Something from the outside has to act on it. And that something is called impulse.
Impulse is basically the kick. It's the push. Now, don't let that little integral sign in the formula scare you off. All it really means is that impulse isn't just about how hard you push something. No. It's about the force you use multiplied by how much time you apply that force. The how long is just as important as the how hard.
And would you look at that? We are right back to our tugboat. It's not pushing with some insane world-breaking force. What it is doing is applying a steady, small push for a really, really long time. That small force, multiplied by all that time, adds up to a huge impulse. And that is what's big enough to change the momentum of that giant ship. See? It all connects.
Okay, so we've got momentum. That's the state of motion. And we've got impulse. That's the thing that changes it. So now let's put them together into one incredibly powerful idea. You can think of it like a simple story in three parts. Part 1, the object has its starting momentum. It's just doing its thing. Part 2, the action, an impulse, a push, or a twist over time comes along and acts on it. And Part 3, the result. The object has a new final momentum.
So here's our before picture. You don't need to get bogged down in the details of the diagram. Just think of this as a snapshot of the object's total motion strength before anything happens.
All right, now for the action. This diagram shows the impulse. This is all the kicks, pushes, and twists from the outside that happen over a little bit of time. This is the event itself.
And boom, here's the aftershot. That initial momentum has been hit with the impulse, and what you get is a new final momentum. As you can kind of see from the drawing, the object is now moving or spinning in a totally different way. So the whole thing, the absolute key takeaway, boils down to this one beautiful, simple equation. The motion you started with, plus the change you applied, equals the motion you end up with. That's the principle of impulse and momentum. It is the secret sauce for predicting how pretty much anything is going to move. Okay, so that's the theory. But what's the payoff? Why does this matter in the real world? Well, let's use this idea to look at something you've probably felt yourself. This beast of a machine is a Sharpie impact tester. It's basically a giant, heavy pendulum that engineers use to see how things break. And by using the principle of impulse and momentum, they can figure out exactly what's happening in that split second of a high-speed collision.
And in doing all this testing, they stumbled onto something really, really cool. It turns out there's this one magical point on a swinging object where if it hits something, the jolt at the other end, at the pivot where you'd be holding it, is basically zero. The hit just feels perfectly clean.
This is just brilliant. The textbook actually calls this point the center of percussion, and it's defined as the place where there's no reactive impulse at the pivot. Listen to this quote from the source. It's where no stinging or little sensation occurs in the hand of the player. Sound familiar?
That's it. The center of percussion is just the nerdy physics name for the sweet spot. You know that feeling when you connect with a baseball or a tennis ball just right, and there's no rattle, no nasty vibration in your hands? You've just hit it perfectly on the center of percussion. It's not magic, it's just pure physics.
So think about it. From a little tugboat nudging a giant ship, all the way to finding the sweet spot on a bat, the physics is exactly the same. It's all about that simple idea. A push over time changes an object's oomph. So now that you're in on the secret, what's a collision you see every day that you'll just never look at the same way again?